Hello, welcome back to the LOOC. In this segment, we look at the concept of polymorphism that allows us to perform generic programming. We look at how to use overridden methods, how to create abstract and virtual methods and classes, how to determine an object's type at runtime, how to create and use sealed methods and classes, how to declare and implement interfaces, and how to perform operator overloading. Polymorphism is the concept that in object-oriented programming we have the ability to write applications in a way that the same line of code can trigger multiple different ways of execution during the running of a program. This most often happens by using derived class objects that share a base class, and when we make a call to a base class method, then different behaviors are triggered depending on which derived class the actual object belongs to, as determined at runtime, even though at compile time, when we write the code, the same line of code is treated as a base class method call. This use of polymorphism promotes extensibility. An example would be a base class quadrilateral, of which there are various derived classes, including rectangle, as well as square, parallelogram, and trapezoid, and a base class method of quadrilateral could be, for example, compute area, of which there are different implementations. For rectangles, a different one for squares, a different one for parallelograms, and a different one for trapezoids. And when we make a method call to the base class method compute area, the actual objects on which this method will be called will be derived type squares, parallelograms, rectangles, and so on, and each will invoke its appropriate area calculation method. Another example would be a video game that handles multiple objects which have a common base class called space object and include object like spaceship and laser beam, but it also includes various classes of aliens like Martian, Venusian, Plutonian. And a screen manager application has a collection of this object as a space object array, so this is an array of base type objects. However, the actual object in it, when the program runs, are various Martians, Venusians, Plutonians, spaceships, and laser beams. And when we refresh the screen manager will send the same message, that is, invoke the same object draw for each object, and each object will respond in a particular way, such as a Martian might draw itself as a little green alien with 2 antennae, meanwhile a spaceship draws itself as a silvery disk, like a flying saucer, and the laser beam is like a red beam across the screen. We can use polymorphism to extend the program, so we can add a new type of alien, say Mercurian, that draws itself differently, maybe with 6 legs and yellow, and we can insert this class in the program and use it without any ripple effect on the client code. So the screen manager code invoking the draw methods doesn't have to be changed at all, and it is totally oblivious to the fact that a new type of alien, Mercurian, was now inserted into the application. The advantage of this kind of polymorphism is that when we call a base class method in the code, when we don't know what actual derived typed object will occur and in what order at execution time, we can write the base type method calls in a generic way, and during execution the actual derived type objects will appear, and that this actual referenced object's type will determine which method is to be actually executed. Any object belonging to a derived class is also a member of a base class, but not the other way around. There is an easy relationship. When it comes to assignments, we have to be careful, because in one way we can do assignments, namely when we have a derived class object, we can assign that to a base class reference. But when we have a base class reference and we want to assign this to the derived class variable, then we have to explicitly cast the base class reference to the derived class type. This is called downcasting. Without this, we cannot invoke a derived class method, and it's also, the assignment itself is a compile error. So let's look at an example in a program called polymorphism test. In the main method there are a couple of assignments. The first is an assignment to a base class reference to base class variable. So commission employee is an instance of the commission employee class, and created by a commission employee constructor is straightforward. Also, derived class reference to derived class variable, so base plus commission employee is an instance of that class created by its constructor, is also straightforward. And using methods earnings, that is implemented in some way in the base class and different way in the derived class, we can display this these two employees. Here comes an assignment when we have a base class reference commission employee 2, but we actually invoke the derived class constructor base plus commission employee. And this is fine because a base plus commission employee also is a commission employee. So this constructor call is, and therefore this assignment is fine, and we can write out the results. And here is the what the output will look like. So the first two are fairly straightforward, but the third one is when we have a base class type variable and we assign to it a derived class object reference. If we wanted to do this the other way, we would have to perform an explicit downcasting. So let's look at this program, polymorphism test. So here we have a class, the polymorphism test class. Within it we invoke the constructors. It's important to know that there is a base class defined commission employee that has various attributes: first name, last name, social security number, gross sales and commission rate, 3 strings and 2 decimals, and has a 5-parameter constructor. When we pass in the first name, last name, and social security number into 2 decimal sales and commission rate, and in the constructor we set the appropriate private attributes, and we also implement read-only properties for first name and last name and the social security number, and then properties defined for with a get and set accessor and mutator to the two attributes gross sales and commission rate. There's an earnings method. Note that there is a keyword virtual used in there, which we are going to discuss later. But anyway, this method returns the salary as commission rate times gross sales, and that is a two-string method that overrides the one in the object class. And then there is the derived class, base plus commission employee, that is derived from commission employee. So the colon shows that base plus commission employee is a derived class of commission employee. It adds an extra private decimal attribute, base salary, and has a 6-parameter constructor. So we pass in the same 5 as for commission employee, but we also pass in as a 6 a decimal called salary. Then we explicitly invoke the base type constructor on the first 5 parameters, and then in the body of the constructor we assign the salary, the base salary attribute. There is a property defined, so validity checking is ensured, and earnings overrides the one in the base class because it returns the salary as the base class earnings, that was commission rate times gross sales, plus adds base salary to it. So it invokes explicitly the base class method, implementation of earnings, base dot earnings. So the base keyword refers to the component of this object, which is a derived class object, that is of the base class, half of it, so to speak. And we override the string, the toString method, again calling the base class version of toString, and add to it the base salary. So that's the relationship between the base class and the derived class in this case. And when we test out the workings of polymorphism, then the first assignment is a commission employee, which is of the base class and uses the base class constructor and is straightforward. So is the derived class version, using a variable of the derived class and using the derived class constructor, and we display these two employees using the toString methods. The first one using the base class toString method there, and the second uses the derived class toString method there. And then we create a commission employee 2. Well, actually, we create a commission employee 2 who is a base class declared as a base class type. This is called its static type, that is, or compile time. But then we assign an object to this variable that is of the derived type, and this assignment is okay because a commission employee, a base plus commission employee, is also a commission employee and therefore can be handled as one. And then we display the toString and the earnings of this particular employee. So when we build and run this program, so let me build it. It takes a little bit to compile. And we'll run it. The interesting thing will be in the third case, because it's a question whether these methods toString and earnings, will this invoke the base class or the derived class versions of toString and earnings. And the answer is that because of polymorphism, they will invoke the derived class even though we declared the employee as a base class type, but just by the fact of creating a derived class actual object, use an actual object, when we call an overridden method like earnings or toStrings, the version that will be called will be determined on the actual type of the reference variable, which is base plus commission employee, not the declared type. This is also called runtime binding or late binding, and one of the main methods to implement polymorphism. So let's test this program by running it. And here comes the output. So let me move this here in the corner. So what we see here is that the first two employees are fairly straightforward. So Sue Jones is a base type employee, has the base type employee toString method and earnings. She has a gross sales and a commission rate and earnings calculated based on that, as opposed to the second employee, Bob Lewis, that at the time we created the instance was a base plus commission employee type, and therefore he has a commission rate and a base salary, but a gross sales and commission, but he also has a base salary that Sue Jones didn't have, and his earnings are calculated from those three components. And then when we created commission employee 2 and assigned Bob Lewis to that variable, the way we get the display is identical with Bob Lewis's original display. It includes gross sales commission and base salary and earnings calculated from that, which is characteristic of the derived class object base plus commission employee. It's a longer output as opposed to the base class type commission employees output like Sue Jones. It's only 5 lines, meanwhile these are 6-line outputs. Even though commission employee 2 as a variable was declared to be base type commission employee, but then we can assign an object reference to a derived class to it. Not the other way around though. So if we had a base plus commission employee reference declared and we would try to assign a base class type to it, then we had a compile error unless we carry out an explicit cast called downcasting. So that was that program, and that's how polymorphism takes place via base classes. The compiler determines the variable's class type by what type of variable it was declared. However, at execution time or runtime, the actual objects that the variable refers to determines the method to be used. Related to polymorphism in class hierarchies is the concept of abstract classes and methods. Abstract classes or abstract base classes are classes that cannot be used to instantiate objects. They are too general to create real objects. They really specify only the commonality among derived classes, so they capture the commonality and abstract it into a class. Classes that can be used to instantiate objects are called concrete classes, and they provide the specifics that are necessary to actually create objects out of that. So in our previous example, it wasn't the case because commission employee, the base class, was also a concrete class, so Sue Jones as an object could be created, constructed out of it, and so was the derived class, Bob Lewis did, which is base plus commission employee. But there are situations in which case the base class is so abstract, so general, that actual objects never instantiated based on them. They are only used basically to indicate what kind of attributes and methods the derived classes must have, but they don't necessarily implement these at all. An abstract class normally contains one or more abstract methods, which is declared by the keyword abstract, and abstract methods don't have implementations, so they are really signatures that indicate the name and the parameter list of the methods and the return type, but in and by themselves they don't have an implementation. And if a class contains just one abstract method, the class must be declared as an abstract class. Abstract properties are declared also by using the abstract keywords, so public abstract property type, and property name, and a get and set with no implementation, and that's the end of an abstract property. It can omit implementations for get and set, but the concrete derived classes must provide implementations for every accessor or mutator declared in the abstract property. Constructors and static methods cannot be declared abstract quite naturally, because constructors are used to instantiate classes that abstract classes don't have and cannot have, and static methods are class-wide, so they are also not abstract because they are not used through instances. So abstract methods have the abstract keyword, and this we already so trying to instantiate an object of an abstract class is a compilation error, and typically there's one or more abstract method in an abstract class, and otherwise normal rules of inheritance apply. It's a compile error to implement not to implement a base class abstract methods unless the derived class itself is abstract, but any concrete class has to implement everything that was not implemented in abstract base classes. abstract base classes can be used to declare objects that reference any concrete classes derived from these abstract classes. And as always, base classes, including abstract base classes, can be used to invoke polymorphism, to manipulate them polymorphically. And it is also common to declare an iterator class that can traverse the objects in a collection. We are going to look at the virtual and abstract keywords and interfaces and base classes later. So in the next section, we are going to look at an example problem, a program that uses polymorphism, that implements a program to solve the problem specified in this slide, that a company pays its employees on a weekly basis. The employees are of 4 types. Salaried employees are paid a fixed weekly salary regardless of the number of hours worked. Hourly employees are paid by the hour and receive time and a half overtime pay for all hours worked in excess of 40 hours. Commission employees are paid a percentage of their sales, and salaried commission employees receive a base salary plus a percentage of their sales. The problem is to be solved that for the current pay period, the company has decided to reward salaried commission employees by adding 10% to their base salary. The company wants to implement a C# application that performs its payroll calculations polymorphically. So that's the program we are going to look at in the next segment.